Good morning, everybody. I am excited. We are in algorithms, and we're in the last half of algorithms. So we've got looks like 3 more things to do. Excited to run through these with you. Excited to get on to the next set, which becomes a little more complicated and a little more fun. And so, if you stuck through all these basics, great job. Keep at it, and we are going to finish these up strong. So this one just says use the right hand rule to navigate through a maze. And so the right hand rule was an algorithm that we looked at in the first half, and it just said the right hand rule works well for solving simple puzzles. But did you know you can also use it to move through more complicated paths like mazes? For this puzzle, walk through the maze in your mind. If you always keep your right hand on the wall, you'll eventually reach the last gem. To solve the maze, adjust your algorithm from the previous page to navigate to the gem and collect it. Start with the code from the previous page by copying and pasting, or if you want a challenge, start with all new code. Adjust your code so the character follows the right hand rule through the maze until reaching the gem. Why don't we just try writing it? So we'll say the gem is on the end down here. So while not on gem, we're going to do something. At the end, we're going to collect the gem. That is our reward. So we want to do some certain things. If not, is blocked right, then we know we want to move forward. Oh, we want to turn right. Turn right. If is blocked right, let's go ahead and write this as well. And we may refactor and clean it up and stuff like that. So if we're blocked on the right, we're going to move forward. We know that. If we are blocked on the right, or if we're not blocked on the right, meaning we've hit the end of something, then we are going to turn right so that we can keep that right hand on the wall. That's kind of the clue, the thing that they're teaching us about here. And so we also need to know, like, if I am blocked on my right and forward, what do I do? If is blocked right and is blocked, then I think we want to turn left and move forward. So this would be a situation here. This first corner that we hit, we are blocked on the forward and on the right, so we're going to turn left, and then we'll move forward here. In that case, we're not blocked on the right, so we're going to turn right. And then we are... but we are not still blocked on the right, so we would turn right again. So let's just run this and see. This is not going to work, but let's see where our holes are and what we need to fix. This is a good approach. See what happened here? We get stuck here. So when we get here, I'm not blocked on the right, so he's going to turn right. Oh, hang on. I'm not blocked forward, but I should navigate around that guy, I think. So I'm not blocked right. But instead is blocked right and is blocked. Am I? Let's look. I'm not. Interesting. Oh, he's turning right. Okay, so when he's turning here, we need a move forward there. Let's try that. Still may not be the most efficient, but let's try it. Or we might surprise ourselves here. Oh, nope, we get a little bit stuck. You know, it's not terrible. We have a little bit of an issue here, but I think that may be part of the right rule because we're always following while we're blocked on the right. We may need to come down here. I've got an extra little thing where he tries to move forward here. It's a little frustrating, but I think it's because he's blocked to the right here. I'm just curious. I'm going to see. We're going to move on, but I'm just going to see if I reverse these. Does that come out with a better response? Nope, I run into that wall. Interesting. No, he still does it there too. Nope, I think we had an efficient solution on our first go, so we're just going to go with that. There's lots of solutions to these things. I'm sure we could find something if we really stuck around and hung out for a long time, but we've got code to write, so let's keep it going. I am going to restart this guy from scratch. You've tweaked several algorithms so far. It's time to practice and what you've learned and write your own algorithm from scratch. To complete the puzzle, you'll need to follow the path moving to each switch and then deciding whether to turn left or right. Try to identify a pattern in the puzzle that lets you know which way to turn. Walk through pseudocode in your mind. So let's talk through this as we're looking at this. It's pretty interesting. So we've got a little bit of a dead end over here off to the left. So we know that in this case, left is wrong. And I notice I'm not blocked, but I'm on a switch and I should be going right. So not blocked and on a switch, I want to go right. Then if I'm facing here, I'm on a switch and I'm blocked, and that's a left. I'm on a switch and I'm blocked, that's a left. I'm on a switch. Can I go that way? Yes, I can. I'm on a switch and I'm not blocked. Yep, I'm not blocked and I want to go right. I'm on a switch and I'm blocked. I want to go left. In this case, I'm on a switch. Okay, so this actually works pretty well. So we're going to use our tried and true while is not on a gem. Or I should say not is on gem. We're going to keep moving forward through this thing. So let's start with move forward because we know we're going to walk. If is on close switch, and let's do not is blocked because that's the first one we run into. We know that's going to be a turn right. We also know we want to toggle that switch, so let's go ahead and remember to do that. And then we will keep going. So then let's write if is on closed and is blocked, because that's our next one. We're going to turn left, and we still want to toggle that switch. I think we're good. The only thing I'm not sure is, do the switches turn on and off every time we run this? So let's see. Let's see what we get. This will be a good test. Looks like all the switches were still off. I'm going to run a little faster so we don't watch the guy all day. Move through. Got it. Got it. Excellent. Yes. We're there. All right. That is a great solution. Super clean, super short. I like it. Let's keep going. Ooh, this one looks like a long one from my last answer, but let's see. I'm going to restart that. Ooh, all that code went away. Scary. Okay. Implement the most efficient algorithm to collect the gems and activate the switches. Ooh, interesting. So we could kind of snake through here. Let's just try walking first. So while is on. So while we're not on an open switch, which we know we get to at the end, let's just try moving forward. Actually, let's say if is blocked, then let's turn right. I'm not sure this is going to work, but let's just give it a shot. And then we're going to move forward. Oh, no, that's not going to work. I'll show you why. Let's just start moving. Yep, I don't want to go right there. I want to go left. Interesting. Okay. You know, we know if is on gem, collect that gem. So we're going to go ahead and add that. If is on closed, toggle. But then we need to move forward off of that. But before that, we need to turn. Okay, one thing we know. Let's try this. And is blocked left. Turn right. I don't know that this is going to work, but let's try it. Is blocked and is blocked right. Turn left. And I know I don't have to check for both of these, so just a little bit of efficiency is I can say an else. So if this is true, then this can't be true as well because you can't be blocked. Well, the way the puzzle's set up, you can't be blocked on 3 sides. I'm curious. Okay. We are going to mess ourselves up on those switches, but let's just see. Ooh, we did it. Okay. But we messed up there. Okay. That's okay. We are close, actually, guys. That's exciting. So we've figured out the how do we turn left or right. Now we need to figure out how to address switches. So what is the right time to do that? And we probably don't want to move forward by default on that. We may want to check this earlier and then do our movement. Because that's going to make it an open switch, and we would exit out if that's the last thing we check. It may be as easy as that, folks, but let's... Since I'm checking my switch, I'm also going to check my gem while I'm at it. And let's see what we get. Excellent. Hey, cool. The reason that I did what I did was I noticed that there was this snaking pattern. Ooh, okay. We got halfway through. Oh, we're not blocked. We should turn left here. That is the one spot where we're not blocked on our right. Else if is blocked. we could just keep it this easy and just say turn left. I may be escaping a rule there that follows, but I'm not seeing it. That is a bit of a challenge there. Removing. Yeah, that's going to do it for us. That's a good one. You know, we could probably always improve on that a little bit, but that's not terrible. Adding in that last conditional to solve this little situation here where we get down here and we're blocked, but we're not blocked on the right or the left. How do you handle that? That's really where we got stuck. And so, yeah, I think that's okay. We can move on to Learn to Code 2. I'm going to go ahead and stop the video there for today. Want to thank you for tuning in. Want to thank you for walking through all of Learn to Code 1 with me. And we will start next with Learn to Code 2, which is going to get into some more complex things, some more exciting things. And then from there, we'll start looking at some of the other playgrounds that come out, especially the ones that are related to games and things like that. I think that can be a really cool way to learn code and learn the theory behind it. And so we'll continue with that. Once again, thanks for tuning in. Have a great day.